Hello, I am Greg Devrel at ENS Labs, and today we're going to be talking about ENS as a source of identity in your apps. So first of all, let's answer the question, what is ENS? The Ethereum Name Service is a decentralized, permissionless naming protocol that lives on Ethereum and scales to the entire internet. Basically, we turn complex hex addresses into human-readable names. And so up top, you see my address is OX179A and so on. Obviously, nobody is going to remember this. It's hard to understand. It's confusing, and so on. But instead of that, using gregskrill.eth is a human-readable name that people can understand, and it's easy to send assets to or represent me kind of on-chain and online. So a common way to understand ENS is similar to DNS. DNS is everywhere. It's in the browsers that we use every day. It maps IP addresses to human-readable names. So instead of typing in an IP address in a browser, you type in google.com. And similarly, for ENS, instead of typing in an address, basically anywhere I use this address, gregskrill.eth represents me instead. And so if you can think about anywhere browsers show IP addresses, you should use names. Similarly, anywhere you read or write an you write an address, you should be able to use an ENS name. So on the left, you can see Etherscan, an example of where you would see a list of people sending transactions, and it shows luke.eth sending something in to gregskrill.eth. That is so much easier to understand than something like what's right below it, of me interacting with a smart contract that just has an address, OX554F, and so on. That means nothing to me, but a transfer of luke.eth into gregskrill.eth, very easy to understand, just at first glance. And on the right-hand side, you can see the kind of opposite, right? So not looking at something that happened in the past, but me sending assets to gregskrill.eth. I just type in the name, easy to remember, easy to type, and it just works in MetaMask Wallet and in many other apps across the ecosystem. So these two kind of features are different processes, right? We have forward resolution, where typing in a name resolves to an address, and it's actually a specific address on a different chain. So I can store a different address for Base than I can for OP mainnet, and so on. And same for reverse resolution. So I go from an address to a name, and this is used in the example of Etherscan that we saw earlier. We call this primary names. And as of basically last week, you can also have a primary name for each L2, whereas previously it was just a primary name on mainnet. And so I will talk a little bit more about that later, but that's just on testnets now. So some exciting new stuff to play around with. Anyways, ENS started as this idea of a username, just a name to an address mapping. But really, over time, it's moved into more of a profile. So this is a view of Luke's profile right here in the back. You can see he has a bunch of text records, we call it, basically accounts and general metadata. He has a list of addresses across chains. This is both EVM and non-EVM, so he has a Bitcoin address right there. And all of this is kind of stored attached to his ENS name, because it's really a portable on-chain profile more than it is just a Web3 username. And so you should be thinking about it from that perspective. Similarly, this is, again, the primary name part. When I sign into apps across the ecosystem, it will show me my name, not only my address, because, again, ENS is my portable on-chain identity. And so why is this important? The kind of goal here is that users of crypto-powered experiences should never interact with hex addresses because they're confusing and long and just annoying, right? And then we take that a step further and say users of any experiences should never interact with hex address. So it's ENS's goal to solve this. This is the Ethereum logo, as we all know and love, and the ENS logo is actually designed to be a wrapper around Ethereum, because ENS makes Ethereum and crypto at large easier to use. Yeah, it's a nice little detail that I think some people miss. Cool. And so moving on, what are the different types of ENS names? A lot of people just think .eth is ENS, but that's actually not totally true. So ENS is the protocol, but it supports a number of names. .eth is the one and only native TLD. So that's the one basically that we created, and it is on-chain, and it is maximally decentralized and all of that stuff. But ENS also supports DNS TLDs. So google.com, gregskrill.xyz, I think I have that, and so on. These can all be used as an ENS name. And so anywhere you type a name, yeah, question?
Tom, how does that get involved with the...
Yep. So the question, just to repeat for the recording, is how does a DNS name work in ENS compared to a .eth name? And the answer is exactly the same. Anywhere you can use a .eth name, you can also use a DNS name, like a .com, assuming it's like enabled to do so. So it doesn't work out of the box, but there are very easy ways to configure an existing DNS domain to work within ENS. And I'll show you a little bit of a live example of that in a second. But so just to kind of compare those two things, .eth lives on mainnet Ethereum. It is maximally decentralized, kind of our gold tier, let's say, and it's controlled by ENS DAO, and there is a fee to register those names. DNS, on the other hand, there is actually no protocol fee. So that's one way it differs. The only reason there is a fee for .eth is to keep a healthy namespace and avoid people just holding a .eth name forever. That's not a healthy namespace. Whereas DNS names, they already have that. And so because it's considered a safe namespace, you can use it in ENS the same way you can .eth. Ultimately, one big difference, though, is that ownership is controlled by the DNS domain registrar. So Namecheap, GoDaddy, and so on. It is not as decentralized and on-chain native as .eth, if you want to put it that way. And then both of these names support off-chain and L2 subnames, or really, they both support the same stack of flexible data that you can do with ENS. And I'll explain more about this in a second, but subnames are the idea of having sub.name.eth, similar to how you can in the DNS world. And if you do this, again with .eth or DNS, there is no protocol fee. Developers have ultimate flexibility to kind of build what they want. And this is made possible by a spec called CCIP read or ERC 3668, which I'll show you a fun diagram for in a second. But this is used by Coinbase, Uniswap, Linea, and more out in production. You can see here the biggest one is actually cb.id. That's not .eth. That is a DNS name that they imported into ENS for free and gave out 12 million subnames of, also for free. So Coinbase actually gave 12 million users a human-readable blockchain name without paying ENS a single dollar. And that's pretty impactful when you think about it. And the others are similar, but they use a .eth name. So I'll do a quick overview of how ENS works from the tech perspective. The ENS kind of core registry exists on mainnet Ethereum, and it stores a name side by side with a resolver. And again, you'll notice this registry stores both .eth names and DNS names. A resolver is what's responsible for kind of returning the data that is associated with a name. And so here you see Luke.eth has a list of addresses, text records, and so on. These are just stored internal contract storage, which means it is, again, the most decentralized, but also the most expensive because of mainnet gas. I'll give a little shout out to the content hash record over here, which is basically a way to turn a .eth name into a decentralized website. I'm going to kind of skip over that for now, but happy to take a question at the end for more. An off-chain resolver, which is how you do the subnames like I mentioned previously, basically starts with the same data structure, but you just return different results. So instead of using internal contract storage, you actually revert with this off-chain lookup. And this is CCIP read, this standard for reverting with an off-chain lookup. And what that means is it tells the client to basically get data from elsewhere. So if we look at this diagram, the client, let's say, is MetaMask wallet. The resolver is a smart contract on mainnet Ethereum, and the gateway is an API that you have somewhere in your backend. Right? I want to look up example.eth. I ask the resolver what is the ETH address of example.eth, and it reverts with this off-chain lookup that basically tells MetaMask, again in this example, to basically ask the same question to this gateway. And then the gateway will return some data that it gets from an off-chain data source. That off-chain data source can really do anything. It can fetch from a database, it can fetch from a layer 2 network, and it is really implementation specific. So whatever you want to do is possible with this architecture. And then the cool part is that in this callback function, so where you see the verify decode data, it will actually verify the data that the gateway returns. And so this is how we have trustless L2 subnames. In this callback function, for example, you can check that the state that was returned by the gateway on the right-hand side actually exists on layer 1, just depending on the way layer 2 rollups work. So layer 2 rollups occasionally post their state to mainnet Ethereum, and in this little verify callback function, we can check that it's telling the truth. The reasoning for this is that the gateway can never lie, and this is a trustless L2 setup. So an L2 resolver looks like this, which you'll notice is exactly the same as an off-chain resolver because they both just adhere to CCIP read, and it is really up to implementation-specific logic for how you're doing, where you're reading from. And so, again, the difference between off-chain resolver and L2 resolver is really not too much from the surface. They both use CCIP read. They both read from some off-chain gateway. And it's just the gateway in one scenario on the left reads from off-chain data, like a database, whereas the right-hand side reads data and returns storage proofs from a smart contract on layer 2. And then that verification logic, that last step, is really the difference. The left has arbitrary verification, so you're just trusting the operator of the gateway, where on the right-hand side, you're actually verifying the state root of the layer 2 itself, again, to have trustless L2 subnames on an ENS name, because it is significantly cheaper than on-chain, than like L1 records. Okay, so I know that was a lot, and I will have time for questions in just a few minutes, but first I want to run you through a couple new resources. So I'm going to have QR codes both on this slide and the next slide, and then the following slide as well will be kind of like one QR code that goes to a doc that has all these other ones. So if you miss these first two, it's okay. But I want to take a second to highlight this new tool to issue L2 subnames, and we're calling it Durin. Can you see that? Yes, you can. Okay, so Durin is basically an opinionated approach to building L2 subnames with ENS. This is what makes the cb.id and the linea.eth and the base.eth stuff possible. This has been possible for a while, but just a lot of moving pieces and honestly quite difficult. So exactly for this audience, for hackathon developers that want to quickly build something really like interesting on ENS, we came up with this. And the idea, I'll pull up the GitHub README to kind of go through a quick overview. But this is basically, an opinionated way to do L2 subnames. It makes it super easy. It gives you one contract that you can customize and deploy to a number of layer 2s. And then all of a sudden, you have a layer 2 smart contract where you can register names like sub.name.eth, and that will work anywhere your ENS names work normally. And so, again, you'll have another opportunity to copy this QR code, or the domain durin.dev is just a really easy approach. And so this is a brand new thing. It literally launched a few hours ago. So if you have any issues with it or if you have any questions, this is what we want to see people building with the most. And we will be by the booth in the back, obviously helping people with it. So that's the latest tooling for L2 subnames. And then we have L2 primary names. As I mentioned at the beginning, primary names is kind of the second process in ENS and what really turns it from an address, from a Web3 username into a Web3 profile. Primary name is like anywhere you see an address online, on Etherscan, on a dashboard, anything like that, you should be able to basically turn it into a name. And that process of an address kind of declaring that they want to be known as a certain name, currently on mainnet is only possible on layer 1. And so again, high gas fees. But as of this week, the contracts to do that on layer 2 are now live. And so if I go back to this page, it has information on how you can do exactly that. And so docs.ens.domains will have information on a whole bunch of stuff, including this. But basically, the idea is with Durin, you can create L2 subnames for super cheap, and then you can set the primary name for that account on whichever given chain that you're using via the L2 primary name kind of new feature. And this provides an L2 native experience for your users and also easier for app developers because you don't have to handle every step of the process thanks to Durin like you would have had to. So the combination of these two tools is kind of what we're looking for this weekend and the main prize, which I will talk about in a second. But I'm just going to leave this screen up here for a second because this has a link to a Notion page that includes basically quick start guides, snippets, contact info, etc. on all of the stuff that I just discussed. And it looks like a couple of people are still scanning, so I'll keep this up here for another second. Cool. And then these are our prizes. So based on everything that I just explained, the three things that we're looking for the most, or really the two things, are best L2 subname experience that is built with Durin and uses L2 primary names. This could be naming smart contracts. This could be onboarding a new user through some consumer application, and setting their primary name right away. And kind of anything else that you might come up with. We think this will be the most popular way to implement ENS going forward. And so this hackathon is really the first place that we're going to see people use it. So very excited about that. The second that I forgot to update the emoji for is about most creative use case of ENS. So obviously a lot of people are into AI and agents right now. If you're building AI agents, maybe you can think about naming that with an ENS name. And so, for example, if you're using XMTP or some messaging protocol, you can go to message agent.eth effectively and get certain functionality, whereas a different agent would have a different name. This can also use Durin if you wanted to. So it's just like creative use case plus L2 primary name, or just a creative use case on your own that could be unrelated. Another example here is something privacy related that we'll kind of leave up to you, but have some ideas if you want to come by the booth and ask questions. And then lastly is best use of ENS. This is likely to be an L2 experience. So there will probably be two winners of the first prize and the last prize, both being L2. But generally, any ENS implementation is eligible to win best use of ENS. Excuse me. And these prizes will total $10,000. So again, that is what I have for you. We have 3 or 4 minutes for questions, I think. But this is the same QR code that was on the previous page, so I'll just leave it up here for a minute as I take some questions. But yeah, thank you for coming. Yeah. Can you say that again?
For example, we have a domain DNS name, TLD, .com something. Does it play nice with the Durin or the primary names? Do we change the resolver in?
Yep. So basically, L2 primary names work with any type of ENS name. That can be .eth on mainnet. That can be .eth on layer 2. That can be .com. Really anything. Yeah.
Is there any plan to make any name that is not a subname also configurable through an L2?
Yes. We actually just announced this week that ENS will be launching a chain called NameChain that is not really ready to be hacked on quite yet. So in the future, yes, but for the sake of the hackathon, no.
Thank you.
Yep.
I have a question about during dev. I used the CCIP tools with Off-Chain Solver before. What is the difference between Off-Chain Solver and this?
Yep. So the question is, what's the difference between CCIP.tools, which is another tool that we have, and Durin? Basically, CCIP tools is built for totally off-chain kind of setups, which means reading data from a database or something like that. And it has like signature verification. So it's just trusting that the operator of the gateway is returning the results that it wants to. Whereas Durin takes a different approach, and instead of reading from an off-chain database, it reads from a smart contract on layer 2. And so if I go over here, you'll see in the Durin repo, which is linked from durin.dev, there are a few smart contracts. And the one that you're actually going to be reading from and customizing is this. And so you basically see a register function. It stores that register function in this registry. And when I go to resolve a name, like let's say name.durin.dev, because you can have L2 subnames under a DNS name, then you would end up basically reading from this layer 2 smart contract. So TLDR, the difference is CCIP.tools is built for off-chain data sources like a database, whereas Durin.dev is built for L2 stuff. But cool, I hope that answered your questions. I think we are out of time. If you have anything else, we are at the booth by the stage in the back corner. So hope to see you there.